In this video, you'll learn how to perform primary data collection. That is, how you collect the relevant microplastic samples for your study. Systematic collection of primary data is a key part of field-based research. You should always use standard data collection methods. In this way, other researchers will be able to validate your research. It is important that you know how to collect, label, transport, register, and store your samples for data analysis. So please follow the instructions provided in this film and remember to check available literature for further details.
I'm a student of environmental science, and my research work on the microplastic in Zanzibar. The marine litter and microplastic are the very crucial issue along the world because plastic is the most material that are found along the area, especially in the surface area. Surface along the sea and along the ocean. And the plastic has a problem. That's a problem because to the living organism, especially microorganism and other living organism in the sea, this microplastic afterward they can go through the food chains, and after that they can end to the living tissue, especially human and higher animals. First of all, we should have a tape measure or field tape, and we should have the basin, that is aluminum or metals one, about 5 basins. We have the shove, also aluminum, and we have this one, the quadrant or the square quadrant. This should be a metal one or the wood one, not a plastic. So through this quadrant, where we're going to count is the sampling for microplastic. And after that, we take a measure of the beach. We can't use all the beach area. We take a transect. The transect for our Zanzibar beach, we should measure about 50 meters. In our measurement of the transect, we measure 2 transects nearby along the area we want to make our sample, the population area. For example, our beach has more than 300 or 400, but we only considered 100 meters. For that case, we measure 2 transects, each of which has 50 meters. And inside of that 15 meters transect, we find some replicate. The replicate should be 5 replicates in each transect. So we use the quadrant of that I mentioned before, that is 50 by 50 centimeter. We use this quadrant, within our transect. So the quadrant should have the mark or width about 2 centimeters deep to the sea, and not more than that. We use 2 centimeters because it is the area where we can find those organic and the organic material such as living organism, and also their microplastic should be stuck in on that area and not far deep on the land. All those replicants, 5 replicants from the quadrant, we take all of them independent. So we use some basin or pot, metal pot, and we put them each in different spots. And after that, we measure those quadrants. We take a sample, for example, and each pot we should count them, or you should measure them, or put the number, because we don't use 2 replicates on the same pot. So for that case, to avoid those contamination, so you should put the number of each replicate, and you find that you leave them by using any material that is a metal one. Then after that, we take it to the laboratory for the other analysis. So after field work, now we have a 5 replicates who are already collected in the field. We have from transect 1, 2 up to the 5. And now we want to determine the moisture content of each replicate. Before we take the replicate or the amount of those samples, we homogenize the amount of the replicate. That is, we are going to homogenize. Take this one, because if you take The upper layer, maybe water can be, all water come to the bottom surface of the sample. So first of all, we will homogenize the replicate, all of this. Then I think this is ready now. And before that, you can use what is the number of the content. This is station number 5. So we take a marker pen and you take a sample and you put the number of the replicate before. You can't forget the number of each replicate. So this is bed trust number 5. So this also here should put bed number 5. And we tag a little bit amount of this replicate. Just in a little bit. So this is our number 5. And we count them, and we're going to measure all sample here. So we have mass of this sample, our subsample is 54.4. So we take this sample here, we put somewhere here to make it to dry. So this is what we call the weight of the replicate 5. So we put it in the oven if possible. If we haven't an oven, we put it on sun, or we can put it at the room temperature until for the one night. But if we are going to dry it on sand, please mind that we avoid contamination. So we put this, we cover it with the aluminum foil, and again we write it as bed trust number 5. Now we put it on sand for some time to make it totally dried. And after dried, we can come again to measure in order to take a difference, how much weight is lost. We leave our specimen here for 2 to 3 hours till it dried. And this will help us to measure the moisture content of our replicate, because we count the difference between the weight we measure before and that one we measure after the 3 hours. That we can count the amount of water or moisture weight lost. The weight lost will be considered as the moisture content of our replicate. So at the time we are waiting for this specimen to dry, we continue with the process of microplastic analysis. In the second process here, we are going to analyze our sample of sand to find the amount of microplastic present there. Here you want to make the separation of our microplastic from the sample. Now we have a 80 packet here of sodium chloride, each of which have half kilogram. So before that, we want to make sure if this is exactly what we need, we take all of them, if possible, or half of it. So we hope that this is maybe 1.5 kg, but we're not sure. That is 136.5. It's not exact 1.3 kg. So we take this, all of this, and we put in our area what we are required. Then we account for the other one. Here, the bucket we are going to use for putting our solution. Put it here. Our measurements, we want about exact 4 kg, but it's missing about quarter of the kg, but it's okay for our measurement. And now we measure about 10 liter for our salt to make a solution of our saturated solution. We make 10 liter. Yes, this is 2 liters. Now we're going to make a solution or saturated solution of 10 liter. And after that, we should to stir it. We already make our saturated solution of sodium chloride. We are waiting for them. And now we want to measure our sample or our replicate. We continue with our replicate. And the first step, we have to sieve it through the 5 millimeter sieve plate. This is a sieve plate, which is the square here, is each of which is 5 millimeter 5 millimeters. So we sieve all of our sample through this. And here you count for the plastic. But now here we have only just the organic one, which is not our concern, and the stone. This is not our concern. If there is no any plastic residue, we leave it as it is. Now here we already sieve it in 5 millimeter sieve plate, and we have our back here. So we cut this into 2 parts: the 1 kilogram replicate and the rest. The rest should be higher than 1 kilogram, but we must consider that the one first should be 1 kg, and we use this 1 liter because the 1 kilogram is approximately to 1 liter. And then this 1 kg, we want the volume of this one in mils. So make sure you count exactly what is 1 kg. Make sure that we measure that there's some space here, so we want to tighten it to avoid the empty space here. And so it's about 600 mils. So this is 1 kg, the volume is 600 mils. So count it. Yeah. Replicate 1 kg, 600. Okay. Then we take all the rest here. 2. This is 2 kg. So this is 1012. So 2 kg, replicate 2, rest. This is 2 kg, and the volume is 112, 1.2 mils. We have 4.43 kg. Now our rest replicate is 4.4 kg, all of this, but this one is only 1 kg. In the first replicate or 1 kg replicate, we use 2 type of sieve. This one is 1 millimeter, and this one is 0.3 millimeter. Now we are going to make our mass density separation, but before that, we should sieve our solution. Maybe there are some unwanted particles. So first of all, we need only 4 liters for separation the 1 kg sample or replicate. So we measure our 4 liters of our solution, but we make sure that there's no particles that were not needed. So we sieve it using the micro sieve as we have. The 4 liter is enough for our replicate here. 1 millimeter should be at the top, and the 0.3 should be at the bottom, like this one. And we take it here, and then we put our sample here. Now we start the separation for the microplastic. So we tear it for about 5 minutes. So as we know, plastic particles are lighter than water, so they must be move up and they be suspended in our solution. Yeah. So we use this procedure at least 2 times because maybe there are some particles are not separated. Now, as you see, there are some particles in all ratio, in both ratios. This is a particle or residue in for greater than 1 millimeter, and this one greater than 0.3 millimeter. So here, after that, there from this, we can count for the microplastic. Microscopic analysis, we use fresh water here, and we use dropper here, drop bottles. We put some water, fresh water. And the petri dish that you are going to use, you should be number it. For example, the petri dish that you are going to use for 1 millimeter should be numbered as Betras, as we remember, it was Betras number 5, Bet 5, and the ratio is 1 millimeter. 1 millimeter. Maybe, I think 3 of them is enough. So now we start the separation our microplastic or plastic possible. We use only 3 petri dishes, I think enough for a sample. And I take the top one. We have about, which is 1 millimeter, 1 millimeter sieve plate. Yes, I think it is all throughout. Then we cover it. The sample for microscopic is ready for our first replicate, that is 1 kg or 1 kilogram replicate is ready. Now this is waiting for the microscopic analysis. We have a sample that is range from 0.3 millimeter and the other 1 millimeter in size. We start with the big one. We use the such kind of microscope known as the digestion microscope. I will put them some plastic nearby, all of them. Just put them nearby. Now we start with the microscopic detection. And as you know, we have 2 samples. This is 1 millimeter, and we should have a 1 millimeter. The vials, this is 1 millimeter vials, and this is 0.3, should have 0.3 vials. Also, we put some fresh water, not full of them, just half of it is enough. Then we start to find whether they are plastic or plastic possible. You should put them on here and count them. This is not a plastic, but this one, the other one, white, this is a plastic also. This is white. You can put this here, and you turning again into the area where we put a white color fragment. We have 1 thread here. So here we can find about 6 pieces here of different size and different shape, including color. Here we finish for the microscopic analysis. And after that, this one going to polymerization or polymer analysis or polymer detection. Here you can find what kind of plastic is there, and the composition, even the functional groups, or what is the material or the group, whether there's heavy metal or what kind of plastic is that